There we go. And now I'll start sharing my screen, and then we can see what we can dig up from the registry profiles. So can everybody see that?
Mm-hmm.
So this is the Gitlab Registry, the profiles we get from there. What we're looking at here, I kind of summarize this every call like this a little bit, and somebody's always around to like improve my wording. So please, Igor, if you wouldn't mind improving after I'm done, that would be awesome. So what we're looking at here is the profiler is running, and it takes a sample. The samples, like the length of the sample is about 10 seconds. And then it looks, in this case, what's happening on the CPU during these 10 seconds. And now we're looking at an aggregate of all of those samples collected over the past 7 days. And then we're looking at averages. So for the 10 seconds average sample, the registry process was spending 1.3 seconds on the CPU. So that's not a lot in total. And then from that, we can see what it was actually doing. So most of the time, this is serving requests, I think. And one of the things that popped up is like we're building a URL from a request. And we seem to do that a lot. Maybe we don't need to do it that much. I don't know exactly what's happening there, but that was one of the things that I noticed when looking at this for the first time. Yeah, that's about the short of it. Any questions around this already, or anything you want to note?
Yeah, I was kind of expecting something like this because the current routing logic, it's a little bit on the creative side. So yeah, it's almost like a VSL around a custom struct that is then passive everywhere, and it kind of treats everything automatically with a lot of regular expressions, which is also showing up there.
Yeah, that's. I was meant to ask that because we have these are regular expressions that are being compiled. But what is, because here we're also compiling a bunch of regex, and I was wondering what that was and why the stack is so deep.
Yeah, so basically this is used all over the code because every request for the registry contains the repository name. And then with that repository name, we do a lot of stuff like finding the right place to get objects from the object storage, manipulating the caching, and also even the routing is handled with that as well. So yeah, it should pop up quite often. There's definitely room for improvement, but I think that we looked at this in the past. But it won't go away without a more serious rewrite of the routing logic. We also have quite outdated dependencies for the Mux router and the Gorilla handlers as well. So bumping those, I believe Eli already pushed an MR for that. Might help in the midterm, but we really need to rewrite the routing logic.
Well, all the small steps should show up here. You can compare versions of the app as well. So if you deploy a new version, you want to compare the old one to the new one, you could use this for that in theory, because we don't have a lot of different deployed versions yet. So
yeah, that is good.
Yeah, it's also worth noting, like here we're seeing that the process isn't actually spending a lot of time on the CPU. And I also, like, I don't think that the registry is, like, I think it's one of our best performing services, like in terms of alerts and whatnot. So Like we can look at these things here and see where there might be room for improvement, but things are already not bad at all.
Yeah, mostly because most of the time happens with the network. So communicating with Google Cloud Storage and ending URLs for downloads and uploads from clients to cloud storage, basically.
Yeah, I guess one related comment is that these flame graphs are always to be considered in context of what the service is actually doing. And so depending on how many instances of this that we're running, maybe 10% of 100 instances, like might be a lot, and we could actually save quite a bit on capacity there. So it's, you always need to kind of consider what is the actual usage. Are we using a lot of CPU across the board for this service? And the same for other resources like memory, which we can get into shortly. But maybe before that, one point that I always find kind of, well, it's kind of hard to read these flame graphs. So have you had any experience to flame graphs before?
We looked at them in the past when we did some optimizations for the garbage collector. Also that it's much easier to identify because there are much less moving pieces, so it's much flatter.
Yeah.
When you were doing optimizations to the garbage collector, was that to the garbage collection itself, or was that to object allocation?
No, it was to the algorithm. It was basically mostly around the number of network requests that are required to do the analysis and the deletion as well. So basically cutting the time, and in some cases we also cut the memory usage as well. But the main driver was cutting the execution time.
Right. You're talking about the garbage collection feature of the registry.
Yeah. I got it. Like I'm a.
Oh yeah, not the language.
not this garbage collection bit, because it's showing up as a big thing here, but that's because the overall sample, like the time spent, is quite short. So let's have a look at the memory usage. Here we can see this is all the memory allocated over the 250 profiles on average. So we're looking at the average of 30,000 profiles. Actually, Igor, perhaps you know this, like how does this averaging work? What is over 250 profiles, but here we're looking at all of them?
Yeah, that I have no idea what that means. It might mean that it's taking 250 samples out of that larger pool, but I don't know for sure.
So the biggest, this is probably what you were talking about, the upload purger. So where you were doing the optimizations?
Not really. The one that we did optimize won't show up because we are not using it for gitlab.com. Only self-managed instances can run the current offline garbage collector. So it won't show up here. What shows up here the most is the walk function. And the biggest reason for that is that, for example, to get the list of tags on a given repository, we have to walk through a series of folders, list them, and then continue down that route until we have everything enumerated. So that's quite expensive.
That's going to be something that we, because I just came from reviewing a merge request by David, I think. That's going to be deleting a bunch of those by walking through them. I think, like going through the old repositories that are in there. So that might be something that we need to keep an eye on as well then. If we're, what it's going to do is going to take all the repositories that haven't been cleaned up in, I don't know when the cleanup feature was introduced, like in GitLab, the cleanup policies.
Oh yeah.
So
Yeah.
we're going to go start cleaning those old not used repositories up, and that would mean requesting the tags of these repositories over like that could be a lot of tags. So then we might have to keep this into account, that it might grow the heap when it's loading those tags into memory to serve them back to GitLab Rails.
Yeah, that's true. That's one of the reasons why we wanted to do it on incremental basis. So start small and see how it behaves, because that will put a lot of load on the registry.
Yeah. As far as I know, the rollout is planned to start with on a project basis. So we just pick a few projects, and then perhaps we can do a percentage based per project. So, but it's nice to see that here. The other thing that we could look at is the allocated heap. This is the memory that's allocated but not released during the runtime of the sample. So anything surprising here that shows up? This might be because it takes a while, so it extends like because it takes a while, it extends like the sample finishes before the memory is returned, and the upload is finished.
Yeah, because there is a request that first starts the multi-part upload, and then we kind of keep that open until the client finishes uploading all of the parts. And then we also see that the URLs, the URL building is going up again, because again, this is also used to construct the paths where we need to upload the data to in the GCS bucket. So it's used everywhere, basically.
Yeah.
Right. So caching that would probably also alleviate GC pressure.
Yeah, somehow. Yeah. The only problem is that because that is used everywhere, changing it will affect everywhere as well. So it needs to be, we need to be careful about that as well.
I recently saw an issue for adding, I haven't read it all complete, but you plan on adding a database to the registry and to lookups for containers and tags in there. Is that, did I understand that correctly?
Yeah, that's right.
What's the reasoning behind doing that? Like, what's the plan for that?
Well, the main reason is that we can't run garbage collection on gitlab.com, and the registry has grown beyond the desirable. So we need to be able to clean that up. But to clean that up, and because mainly layers from images and also some of their configuration files as well are stored deduplicated in the cloud storage buckets, which means that in order to determine if we can garbage collect them or not, we first need to determine if there is any repository that's still relying on that specific code. And to determine that, we have to scan all repositories, and with the existing structure, that means traversing the whole file structure, folder to folder and file to file, finding all of the references, and then calculating the blobs that were not referenced anywhere. But to do that, we need to be offline, which we can do for gitlab.com, of course. Otherwise, we would be in read-only mode for 2 or 3 weeks.
Because someone can push a new image that references
and
something that we're trying to collect. Yeah.
Exactly. And basically invalidates whatever calculations we have done so far. So that can happen, and the only way to be able to get those results fast enough to not be invalidated by an incoming request is by having a SQL database. So that's what we want to do, migrate the metadata. So the repositories that exist, which manifests are in those repositories, which tags as well, and which blobs are referenced by each one of those artifacts. Put that information on a SQL database, and then we can do all of the querying using SQL instead of HTTP requests against GCS.
Yeah, that could also clean up the speed up the cleanup on the Rails side, because like right now Rails needs to make a request to the repository, and then the repository needs to check object storage before it can get back, which is why
it will actually have to be, probably it will have to be in the opposite direction. So first, ideally, we would run the expiration policies so that we can delete as many tags as we are able to, because we will then have to migrate the existing repositories from the current registry to the new one by the metadata database, which means that the less tags that exist, the faster.
The less work we need to do.
But yeah, in the end, for example, once we have the database, the time that we are spending with the walk in the other flame graphs will vanish, because we will no longer have to search the bucket.
The walk was mainly allocated memory, I think.
Yeah.
Here on the heap.
Yeah, so that will go away, because we will not need that function anymore.
Mm-hmm. All in all, this isn't that bad, 502 megabytes neither. So like, yeah. Andrew, is there something you saw here that you want to call out?
No, sorry, I was late. I got distracted by something, and so I was, oh, I'm late. But it's really, I'm just really happy that people are looking at these profiles and spotting things. So that's awesome.
Well, the thing apparently the thing that we spotted here was already known in the registry, which was mainly the URL building and these walkers. So work has already been done.
Awesome.
Any more things people want to bring up here?
Not really. I think the main culprits here are really the walk function, which will go away without doing anything about it, hopefully, and then the routing logic and the regesps around that as well, but that will have to be rewritten from the ground up.
Are there issues for that already? Like, because
I'm not sure if we have one already, but if we don't have one, I'm going to open it right after.
Cool. Thank you very much. I'm going to ping you on the main issue then to cross-link the issue you created.
Okay.
Thank you very much for your time. I'm going to pause this recording. If there's anything more to add, feel free to reach out. Any questions, anything, you know where to find us.
Thanks.
Thank you very much. Bye-bye.
Bye-bye.
Bye.